Alright, well, I think we're good to go.
Yep.
If you want to start.
Sure. Okay, yeah, so welcome to the review. So just so you know, this is being recorded, but it's just a screen recording, so like your face won't appear in it. Perfect. Okay, so these are, I guess, the topics we're going to cover. There's factors, fractions, real numbers, exponents, order of operations, algebraic expressions, and algebraic equations, and logarithms. Okay, so first thing we'll go over is factors.
Right. So we'll just go through these and make sure that you understand each of them. So factors of a number are numbers that multiply to that number, or in other words, they divide in with no remainder. So it's like, I don't know, like 6 divided by 2 equals 3. So 2 would be a factor of 6. And then when you factor something, you write it as a product of numbers. And there might be multiple ways to write that depending on the number. And we call it prime factorization when a number is written as a product of only prime numbers. So anything you want to review from that, or does that sound pretty? And we'll have examples on them too.
Okay. I'll wait till the end of that.
Okay, sounds great. You want to take over?
Okay, perfect. So our first problem is to find all of the factors of 24. So the way I like to do this is I start with 1 because that's a factor of everything except 0. And then 1 times 24 is 24. And then I go to the next number. 2 times what is 24? That's exactly right. And then there's 3 times what is 24 is 8. And then 4 times 6 is 24. And 5 doesn't go into it. And then 6 does, but then we circled back. So we know we got them all. So yeah, you can make them into a nicer list, but those are all the factors of 24. Great. And yeah, looks like we got it.
Right. So find the prime factorization for 180. So the way I like to do this is I like to make the tree. So you can break it up into factors. So we can see that 10 goes into it and 18. And then what could we break 10 down into?
2 and 5.
Yeah, exactly. And then what could we break 18 into?
3 and 6.
Yep. And then we have one more that we need to break up because 6 isn't quite prime. Yes, exactly. So we go until the ends are all prime. And then to show that it's the prime factorization, we just put all of them multiplied together. So we got 2, 2, 3, and then 5. Oh, and we missed a 3. Oh my goodness. 3 as well. And I like to cross them out so I make sure I don't miss them. And then that should be.
Why do you multiply these ones and then a list for like just the factors? Like,
Oh, for sure. So the prime factors, all these numbers multiplied together is going to equal 180. So the idea of prime factorization is just to represent 180 as only prime numbers. Yeah, great question. Do you have any other questions on that? Okay, awesome. You got it.
Okay, so least common multiples, or it's like when you're given a group of numbers, the least common multiple is the smallest number that is a multiple of all the numbers. And multiples are like things that the number can multiply to. So like multiples of 3 are like 6, 9, 12. Yeah, like things that can be multiplied to get to. And then to find the least common multiple, you could either list all the numbers out and find the smallest one that is in all the lists. That method usually takes longer, or you could find the prime factorization and find the things in common, which is a method I like better, but both work. And then a number is a multiple of itself, like multiplying by 1. So like one of the numbers in the list might be the least common multiple.
Okay, so we're going to find the least common multiple of the following numbers. So it wants us to list the multiples. So some multiples of 3 are 6, 9, 12, 15. We could keep going. And then 4. What are some multiples of 4?
8.
Yep. 8, 12.
Hi, are you doing something in here?
Hey, yeah. We're doing the CBE review.
16.
Yeah, 16. And I think we've gone far enough with that, but you could keep going if you need to. Okay, and then we'll find some multiples of 6.
12, 18, 24.
Yeah,
So they'll have 12.
exactly. Yep. So they all have 12. And that's the least one in common. So the least common multiple will be 12. That should be right. Perfect. Do you have any questions on that one?
I think I'm good.
Okay.
Okay, so the next topic we'll look at is fractions. Okay, so fractions, you can think of them as division problems. So like if we have like 6/3, that's 6/3, but it's also the same as 6 divided by 3. Like those are just two different ways to write it. They're the same thing. So if A over B equals C, if C times B equals A. So this is kind of just like division is the opposite of multiplication. So like A divided by B equals C, so C times B equals A. Then the top of the fraction, like this part, is called the numerator. And the bottom right here is called the denominator.
Perfect. So to multiply fractions, we're going to multiply the numerator together and then we'll multiply the denominator together. So if we have like a fraction here multiplied by this fraction, we'll multiply across the top to get the new numerator. So 1 times 1 is 1. And then we'll multiply across the bottom to get the new denominator. So 2 times 3 is going to be 6. Okay, so to divide by a fraction, we will multiply by the reciprocal. And the reciprocal is just that fraction flipped. So like if we had 1/2 divided by 1/3, to take the reciprocal of 1/3, all we're going to do is flip the fraction. So we will end up with 1/2 times 3/1. And then we'll do the exact same thing as above, we multiply across. And then you can simplify while you are multiplying, and there's a couple of examples of that coming up that we'll show.
Perfect. So now we're going to divide 35 over 24 divided by 15 over 8. So first we just keep the first fraction how it is. And then we change this division into a multiply. And then flip the second one. Like that. Then one thing we can do is simplify this as we go. Like it still works just fine to multiply it and then simplify, but it's sometimes easier to do it this way. So what's one thing we could simplify?
We could take 5s out of 35 and 15 and 3s out of the other two.
Yeah, perfect. Yeah, so 35 and 15, you can take a 5 out. So that leaves a 7 here and a 5. Oh, we took a 5 out, so it leaves a 3 here. And then the 24 and 8, we can take 8 out of both of those. So that leaves this. So then we have 7/3 times 1/3. Then when we multiply it straight across, 7 times 1 is 7 over 3 times 3 is 9. And we get 7/9. Have any questions on that one?
I think I just need to get more familiar with it. I don't think I was taught that in high school.
Oh, really?
Yeah, so like there's been a few things in lecture. I'm like, my math teachers in high school were not very good.
Oh, okay,
So-
yeah, fair. Yeah, yeah.
One of them even got fired, so that's
Oh, no.
I have confirmation.
Yeah.
But I think I'm good on that. And if it doesn't have like, if you can't like break it down, just go across.
Yeah, so like, it'd work just fine if you did 35 times 8, and
Just
then
have to
24 times
simplify it
5,
later.
yeah, and then, yeah, and it's usually like bigger numbers, so it's a little trickier, but yeah, you can totally do that.
Sure. Well, I like that way easier.
Yeah.
Awesome. All right, and then adding and subtracting fractions. So this is a little bit different than multiplying and dividing. So adding and subtracting does have the same procedure. To add or subtract, the denominators must be the same. So the first step is to rewrite the fractions with a common denominator using the least common multiple of the denominators. So to do this, we're going to multiply each by a fraction with the same numerator and denominator, so equivalent to 1. Then this will be equivalent to the first expression, but the denominators will be different. So I'll do an example super quick because that's like a lot of words. So
Yeah.
we'll go with our 1/2 and 1/3 example again. 1/2 plus 1/3. In order to add these together, we first have to get a similar denominator. So we're going to find the least common multiple of 2 and 3. So let's write out our multiples again. Will you give me a couple for 2?
4, 6, 8,
Great. And then a couple for 3.
6, 9, well, there's 6.
And you can already see it, yeah. You already got it, 6. Okay, so we want to make both of these equal to 6. So what we're going to do to make 1/2, to make the denominator equal to 6, we need to multiply that 2 by a 3, right? And then we have to keep it 1. So it's going to be 3 over 3 that we're going to multiply it by. Because that way we're not introducing a new value. Exactly. And then the same thing over here, we're going to multiply 2 over 2. And so what we'll end up with is going to be 3 over 6 plus 2 over 6. Now we have our common denominator. Makes addition super easy. And we just add over the top. Just like that. So pretty straightforward. Do you have any questions on that at all?
I don't think so. I know in the past, like, I'll just like multiply. I never found like the least common multiple. I just would multiply the bottoms together.
Oh,
And I would be working with really big numbers.
Gotcha.
So,
in this
like-
case, that's a great move to make, and that totally works. But yeah, sometimes the least common multiple is easier as well. So yeah. All right.
Okay, so to subtract 4/3 from 4/6, what's the first thing we need to do?
with the denominators.
Yeah, that's exactly right. And do you see something we can make them, that we can do to make them the same?
We can just change one of them.
Mhm,
Over 2
yeah.
times 2 on top and bottom.
Yeah, that's exactly right. So we do 2 over 2, which is equivalent to 1. And then as we multiply across here, we get 8 over 6. Then the second one, we can just leave the same. So then, because the denominators are the same, we can just subtract them. And that leaves us with 4/6. And it says give your answer in simplest form. So
2/3.
yeah, that's exactly right. So if you take a 2 out of both of these, it leaves you with 2/3.
All right. So now we're going to simplify the complex fraction, and it's the same procedure, even though it looks a little bit scarier. So, where do you think we will want to start on this?
Maybe just like start with the bottom to make it just one term.
Yes, I agree. I think that'll definitely be the simplest. So let's just focus on this bottom for just a second. So we have 1/2 minus 1/3, and we literally just did this a couple slides ago, or we did plus 1/3, I guess. So what's gonna be, I guess, what do we want to make the denominators?
The 6.
A 6, exactly. Okay, so on this side, we'll multiply by a 3 over a 3. And on this side, we'll multiply by a 2 over 2, which gives us 3/6 minus 2/6. And that's going to give us 1/6. Okay, so now we'll write out our complex fraction again. 7/8 over, and we got 1/6 here, so 1/6.
And can't we write it like across to do the reciprocal?
Exactly, yes, yep, so this is division, so we can flip it. So what would it look like?
Negative 7/8, just divided across to 1 by 1/6.
So divided by
Or were you
1/6,
asking like the reciprocal?
like that. Well, no, that's exactly right. Okay, and then now what do we do?
And then you just leave 7/8, but multiply by 6 over 1.
Yep. Okay, do you see a way we could simplify this before we do our multiplication?
Like get 2 out of it,
Yeah,
6 and 1.
yeah, exactly. So 6 becomes a 3, and our 8 becomes a 4.
And then it would be 21 over 4.
And then our first fraction is negative, so we're gonna keep it negative.
I don't think it gets in.
I don't think we can either. I think that's the simplest it goes. Okay, perfect. And then we can double check our answer. Nice. All right.
Okay, so the next thing we're gonna talk about is real numbers and like the other sets of numbers too. So here are 3 sets that we use. So natural numbers, they're sometimes called the counting numbers because it's like the first numbers you learned, like 1, 2, 3. Yeah, I guess it goes to infinity. But and then whole numbers, it's the same as natural numbers. It just starts at 0. So 0, 1, 2, 3. Then integers are the same as whole numbers. They just include the negative ones. Then rational numbers are any that can be written as a fraction. So like this, it does go on forever, but it's still a rational number because it can be written as 1/3. And rational numbers include all of the whole numbers because like whole numbers like 5 can be written as a fraction like that. So yeah, this is a good point. Like decimals have to stop or have a repeating pattern. Like this one up here has a repeating pattern. Or anything that stops can be written as a fraction. It might be like a really big fraction, but yeah, as long as it stops, it can be. So irrational numbers are decimals that don't stop and don't have a pattern. Can you think of any? Yeah, that's one of our favorite ones. So yeah, pi, e, or even just ones that don't mean anything, like, yeah, just keep going with no pattern.
What's E?
It's used a lot with like logarithms. It's 2.71, and it just, yeah, yeah, it's kind of like pi is just one that we use for things. Yeah. And then real numbers are any number that is rational or irrational.
So it's every single one that we just talked about?
Yeah, that's exactly right. So yeah, pretty much it's every number you would think of. It just doesn't have imaginary numbers. Like, so no square roots of negative numbers, but yeah, pretty much everything else is.
Imaginary numbers.
Yeah, they're a little odd, but yeah, so pretty much everything we'll be talking about is a real number.
You said on the other side was natural, whole, and integers, right? Like integers
Yes.
are the negative stuff.
Yeah.
All right. So we're just gonna list the sets that the following numbers belong to. So let's start with this one here. What are some sets that one belongs to that you can think of?
Real,
For sure, yep.
And so that one is rational
Yes, it is. And why is it rational?
because it stops.
Exactly.
So 0.33 doesn't stop us, but it is rational.
It is rational only because there's a pattern.
Oh, that's right.
Okay, so real, rational. Let's see what else are our options.
Is it also integers because it's negative?
Close, so, but integers are only,
Or no decimals?
yeah, no decimals, exactly. I think there's one more I can think of. Oh, wait, no, there isn't. I'm so sorry. Yep, so it's just those, real and rational. I don't know where I was going with that. Does that look right to you? Okay, perfect. All right, how about 8?
Natural,
Yep,
real,
yep.
integer, and rational, I guess. So everything except irrational.
Exactly, yep. Which one did I miss? Whole, natural, real, integer, and, oh, rational. Exactly, everything but irrational in this case, yep. Okay, and then what is pi?
Irrational.
Irrational.
But
And
is it
this-
also real?
Yep. Yeah, awesome. You have those down. Do you have any questions on any of those?
I don't think so.
Okay, awesome. Oh, let's see our solutions. Okay, yep, we got that one. We got that one. Yep, we got those ones. Awesome.
Nice. So next thing we'll do is exponents. So here are just some rules that are handy to know. So like this one, when you have two things with the same base that are being multiplied, you can just add the exponents. So like, as an example, if you had like x to the third times x to the fifth, that's the same as x to the eighth. And then this, when you have an exponent that has an exponent, like kind of like a double exponent, you can multiply the two together. So like if we had x squared to the third, we can do x to the sixth, like we multiplied those together. Then this one is similar to the when they're multiplied, except it's dividing, so you subtract. So like if we had x to the 10th over x to the 6th, we could subtract 10 minus 6 and get x to the 4th.
And that's why we can do what we were doing today.
Yeah, so it's exactly right. Like earlier today, we were canceling things out and like, yeah, so that would leave none on the bottom, just 4 are left on top. And then negative exponents are the same as like something in the denominator. So like if we had x to the negative 4, that's the same as 1 over x to the 4th. Can also be done the other way, like 1 over x to the 5th can be written as x to the negative 4th.
So if you were to like do the reciprocal, like had to multiply the reciprocal, but it has an exponent, then the signs change or does it stay?
Yeah, so good question. Yeah, so this actually, like, it's a little confusing because you would think it would make like the end result like negative. So here, I'll use real numbers so it's easier to see. So like if we had like 2 to the negative 3rd, that's actually just 1/8. It sometimes, like I used to get confused all the time and think it was like -8. But yeah, a negative in the exponents just tells you to send it to the bottom.
Okay.
Or send it to the top if it is in the bottom. It doesn't actually like make it negative. That answer your question?
I think that makes sense. Like if you were to,
Are
but
you
also
doing
if
a
you
5 students in here for the office hours?
Give me a second. We're just recording this, but we're almost done. So, yeah.
So, if you were to do like a fraction times like a fraction with an exponent on the bottom, would if you were like divided by, would you, if you were to like divide that fraction And
So-
reciprocal to multiply, would the exponent stay the same or would it be like negative?
Yeah, so good question. So is this kind of what you're asking? So if we had like 1/3 like divided by like 1/x²,
Yeah.
like that? Okay, yeah, so it's gonna erase some of these so I have more space. Okay, yeah, so in that case, you could do a few different things. So yeah, it's multiplying by the reciprocal. So you could either do 1/3 times x² over 1, or you could, if you rewrote this, wait, yeah, actually, yeah, that's just the best way to do it. So you just
So
kind
the
of treat
two
it like
doesn't go
normal.
negative.
No, yeah, because you just flip it. Like, if this was a -2, you could either flip it and like have -2 up here, or you could just rewrite it in this space as x².
Oh, okay.
That kinda makes
So I
sense.
can't like do the other one, but I can do, if it was a negative.
Yeah,
That makes sense, yeah.
yeah, so that was this rule. Then anything to the 0 power is 1. Yeah, so like 100 to 0 is still 1.
Yeah.
Perfect. Any other questions on those ones? Awesome.
All right, so we'll simplify this one using those exponent rules. So what can you see that we could do first?
So we're adding the exponents,
Yes. Yep, we will be.
but then I guess we can multiply the 3 and then -4.
Mm-hmm. Gives us -12. And then we're left with y to the 4th, y to the 3rd, but you just said how we're gonna do it. We're gonna add those exponents together. So we will be left with y to the 7th. So that should be the final answer. Does that make sense? Okay. Sweet.
So yeah, so this one, it's a little more complicated, but if you just take it one step at a time, it's not too bad. So there's a few different options. What do you want to do first?
We just do the -1 and the -3.
Yeah,
and then
so
multiply them.
yeah, so you're saying like distribute this 3? Yeah, perfect. So then we have 2 to the -3 and x. And yeah, I heard you say multiply them, and that's exactly right. So -1 times -3 is just 3. Then in the bottom, what'd you notice about this exponent? I guess I covered it a little bit.
Is it a 1?
Yeah, yeah.
I guess. Wait, does that just mean? My brain's not working.
That's okay. Yeah, so
Okay, sorry, let me catch up here.
yeah.
It'll just be like done once, so it's just 2x.
Yeah, that's exactly right.
I was like,
Yeah.
I'm so worried I'm wrong.
No, you're totally right. Yeah, so anything raised to the first power doesn't really do anything, it's just itself. Perfect. So now one thing we can do is, well, this is just a 2 to the -3. And yeah, there's a few things that we can do to simplify this.
Because we're trying to get rid of the negative, or we're just trying to get rid of both exponents, or?
Yeah, we're just trying to like simplify it and have no negatives.
So do you do 2 to the -3 and it's the fraction, like it turns into a fraction?
Yeah, that's exactly right. Yeah, so we send this to the bottom as 2 to the 3rd. Or you can just know 2 to the -3 is 1/8, or 2 to the 3rd is 8. So we'll have an 8 in the bottom. Perfect. And then these x's, oh, I guess we have an 8 and then this 2 is still there. And then what about these x's? What can we do with those?
Well, they're just, it's like dividing up the x's, so there's just a 2 of them on the top.
Yeah, that's exactly right. yeah. So this one cancels, and we're left with 2 here. Perfect. And then you can leave the x squared, and 8 times 2 is 16. Any questions on that one?
I think I'm good after some brain fog.
Perfect. Yeah. Nice.
All right, and then order of operations. So I don't know if you've heard the please excuse my dear Aunt Sally, but I think that's the easiest way to remember it. You go parentheses first, and then you worry about exponents, and then you worry about multiplication and division, and then you get to your addition and subtraction. Okay, and then algebraic expressions and algebraic equations. I'll let you go ahead and explain this one.
Okay. Yeah, so expressions are like, yeah, they're like a statement. So something like x squared plus 6, that's an expression. So like you can simplify them sometimes. Like if you had like x plus 2x, you could simplify that to 3x. But yeah, you can't.
They have no like equal sign.
Yeah, that's exactly right. Yeah, they have no equal sign, so we can't like solve them, I guess. And then equations do have an equal sign. And then, so these ones, it would be like 2x equals 4. And this one we can solve.
X equals 2.
Yeah, that's exactly right. X does equal 2. So yeah, so I guess the key difference between these is whether it has an equal sign or not. Like, yeah, so expressions you usually just simplify. Equations you can sometimes solve.
So that means just like equations you're solving for a variable or not all the time.
Yeah, like a lot of times you will. Sometimes there will be like more than one variable, so you can't necessarily solve it. But yeah, equations, they just tell you something equals another thing. So they usually have more information. Expressions don't really tell you anything.
They're just
Yeah, yeah.
All right, awesome. Okay, so this is gonna be using the please excuse my dear Aunt Sally and order of operations. Which do you think we should take care of first?
the absolute value.
So the absolute values behave just like a parenthesis does. And it just means that we're gonna take like the positive, whatever we end up with, right? So let's take care of that first. So we're gonna get 15 plus absolute value 4 minus 8 is gonna give us a -4. Yep. Minus 4 squared over, and then I guess we could simplify this denominator. 8 minus 6 is gonna give us 2. And then you're right, this is just gonna be a 4. Okay. So you got 15 plus 4, and then what is 4 squared?
16. Yeah, 16.
16, exactly. Over 2. So we had to take care of that exponent before we could add it into anything else. Okay, and now we have everything pretty simplified. So we should just be able to add and subtract on the top there. So
19, 16, so 3 and 2.
And that's it. We can't simplify that any further. So that's our answer. Perfect.
Nice. So now we can try to simplify this expression. So in order of operations, what comes first?
What is this? Well, I guess we can't really do k plus 1 minus 1.
Yeah.
So we'll just distribute the
Yeah.
parentheses.
That's exactly right. Yeah, so these parentheses, they would be first, but yeah, we can't really do anything with them because, yeah, there's nothing to do. So then multiplication can be next.
9k minus,
Yeah, 9k minus 3, then minus minus 5k, then minus 5. That's exactly right. Okay, so now what?
then just combine the like.
Exactly. Yeah, so we have our k's, So 9 minus 5 gives us 4k. And then we have -3, -5, get -8. And that's our answer.
All right, and then that's all we have in the review. So, yeah, if you have any questions about anything that we went over, or is there anything you would